Today we will begin Section 7.4 Polynomials. We'll start by discussing the degree of a polynomial. First of all, a polynomial is a monomial, or the sum or difference of monomials, each called a term of the polynomial. Some polynomials have special names like binomials, which is the sum or difference of two monomials, and trinomial, which is the sum or difference of three monomials. Now keep in mind that we learned about monomials earlier in this chapter, and you also talked about them in pre-algebra, and they are numbers, variables, or product of numbers or variables. And keep in mind also that you cannot have a variable in the denominator of a monomial. In example 1, we're going to identify polynomials. Determine whether each expression is a polynomial. If so, identify the polynomial as a monomial, binomial, or trinomial. So the examples I've shown you are, the first expression is z, and yes, this is a polynomial because it's a variable, and its special name is monomial because it has one term. In the second example, 5xy plus 6st, it is also a polynomial because it's the sum of two monomials, which makes it a binomial. The next expression, 3x squared plus 4y, is not a polynomial. 3x negative to the negative second power plus 4y is not a monomial because 3x to the negative second is the same as 3 over x squared, which is not a monomial. The last example is 3x squared plus 4x plus 5. This is a monomial or a polynomial because it's the sum of three monomials, which makes it a trinomial. In guided practice 1, we'll try a few together. We'll determine whether or not these expressions are polynomials, and if so, whether they have a special name. The first expression is x, and we know that is a polynomial because it's a monomial. So special name is monomial, one term. 5rx plus 7tvw is a monomial. It's a product of numbers or variables, and it's a sum of two monomials, so it is a binomial. In the next expression, 4x to the negative third power plus 5y, this is not a polynomial because 4x to the negative third is the same as 4 over x to the third. And remember, we cannot have a variable in the denominator, so this is not a polynomial. The next example is negative 3y squared minus 2y plus 4y minus 1. Yes, this is a polynomial. And this one's a little tricky because at first glance you would think there are four terms, but if you look closely we have two like terms here. So if we simplify it, we get negative 3y squared plus 2y minus 1. So it is actually a trinomial. So be careful with those because they sometimes will be tricky. In self-check 1, you look at examples A and B and determine whether or not they are polynomials. Let's talk about the degree of a monomial. The degree of a monomial is the sum of the exponents of all of its variables. A non-zero constant has degree 0, and 0 has no degree. The degree of a polynomial is the greatest degree of any term in the polynomial. To find the degree of a polynomial, you must find the degree of each term. Some polynomials have special names based on their degree. So 0 degree is a constant, a first degree is a linear, a second degree is a quadratic, a third degree is a cubic, fourth degree is a quartic, fifth degree is a quintic, and then after that we just say sixth degree, seventh degree, etc. Generally, I don't use their special names when I discuss them. I'll generally just say first degree, second degree, third degree, fourth degree, and you can do that as well. So far, we've mostly talked about linear polynomials. We will be talking about some quadratic polynomials coming up soon. Let's look at example 2 and find the degree of each polynomial. The first polynomial is a monomial. So to find the degree of a monomial, we find the degree of each of its terms. So we have 7, which is 0 degrees because it's a constant, x to the first, so 1 degree, y to the fifth, 5 degrees, and z to the first, 1 degree. So what we do is we add the exponents together and the degree of this polynomial is 7. In the next example, we have to find the degree of each term, and then we'll choose the largest degree as the degree of the polynomial. So we'll take each one. So 2rt we know is a second degree because 2 is 0, r is 1, and t is 1. 3rt squared, 3 is 0, r is 1, t is 2, so this is a third degree. 7 or negative 7, r squared, t squared. 7 is 0, r is 2, t is 2, so we have 4. And then negative 13 is 0 because that's our constant. So the degree of this polynomial is a 4, or a fourth degree. In the self-check, look at examples A, B, and C and determine the degree of each polynomial. Next, we're going to discuss writing polynomials in standard form. The terms of a polynomial may be written in any order. Polynomials written in only one variable are usually written in standard form. The standard form of a polynomial is written with the terms in order from greatest degree to least degree. When a polynomial is written in standard form, the coefficient of the first term is called the leading coefficient. So this polynomial, 4x to the third minus 5x to the second plus 2x plus 7, is written in standard form. Its greatest degree is 3, and its leading coefficient is 4. So it's in order from greatest to least, the third degree, second degree, first degree, and then 0 degrees, and the leading coefficient is going to be 4. In example 3, we're going to write each polynomial in standard form and identify the leading coefficient. So step 1, we're going to find the degree of each term. Remember, the degree of 8 is a constant, so it's going to be 0. Negative 2x squared is going to be 2. 4x to the fourth will be 4. And negative 3x will be 1. So now we know the greatest term is 4x, and it's positive, so we'll put 4x to the fourth. The next greatest is negative 2x squared, so minus 2x squared. The next greatest is minus 3x, and then plus 8. And 4 is going to be the leading coefficient. Let's look at one together in guided practice 3. Once again, we'll start by finding the degree of each term. So the degree of y is 1, the degree of 5y to the third is 3, the degree of negative 2y squared is 2, and the degree of negative 7y to the sixth is 6, and the degree of 10 is 0. So the first thing we're going to do is write the terms in order from greatest to least. Our first term is negative 7y to the sixth. The next greatest term is positive 5y to the third. The next greatest term is negative 2y squared. And then we have positive y and plus or positive 10. So now it's written in standard form from greatest to least, and the leading coefficient is negative 7. Go ahead and try one on your own in self-check 3. Write the polynomial in standard form and then identify the leading coefficient.